Hello there, Algebra students. This is Mr. Kashi speaking. As you can see, we're going to take notes for the video today. Our topic is our last section of our Chapter 3, which is 3.9, which is the Pythagorean Theorem. And if these notes tend not to help in the way you hope they would, you can always reference the textbook on page 181, and hopefully that'll help out. Our first key point today, we're going to point out the parts of a right triangle. A triangle obviously has three sides, but when we're talking about the Pythagorean theorem, we actually have some names associated with them. So here there are the two shorter sides. They're called legs, and the longer side is called the hypotenuse. And the hypotenuse is actually defined as the side that is opposite of the right angle. Okay, so it's always going to be the opposite side of wherever the right angle is. It's although it's going to be the longest side, it's not part of the definition. The legs themselves, we label them with letters. Usually the shorter side is A, the longer side is B, and then the hypotenuse is labeled with the letter C. And that is going to get into what we know as the Pythagorean theorem. We're going to be taking these names and using them with the Pythagorean theorem. I'm going to go on to the next slide. Throughout the whole video, feel free to obviously pause it and rewind if you need to finish taking notes. So the Pythagorean theorem, we have a right triangle that's obviously denoted with the right angle in the bottom left-hand corner here. And if we were to label them, label the sides A, B, and C, just like we talked about in the previous slide, A, B, and C. The Pythagorean theorem was actually first thought of through the Pythagoreans, who that was a school in olden days in BC that was following the founder of the school. His name was Pythagoras. Back in the day when only one name was needed, and what they found out was if you take these three sides of the triangle and you actually make squares off the sides of them. If we make the square, and obviously if it's a square, both these sides would be the length A, and if you were to find the area of that square, you'd multiply the length times the width, which is the same thing, and we'd get an area of A squared. And if we did that for all the sides, so we did that for B as well, we had B times B and we had B squared, and then up here for the hypotenuse, if we had a square here, and C times C, this would be C squared. What they found out was that the area of the two smaller squares is equal to the area of the larger square. So they came up with a mathematical equation which said A squared plus B squared equals C squared. So, and that is known as the Pythagorean theorem. And this form of the Pythagorean theorem is used best when you need to solve for the hypotenuse. There's another form of the Pythagorean theorem that I'd like you to also be able to use, and that would be C squared minus A squared equals B squared. And obviously the A and the B can be interchangeable. And this would be if you need to solve for the length of a leg. So solve for a leg. This is the version of the Pythagorean theorem that you'd be using. Those are the two equations that you can be using. A squared plus B squared equals C squared for the hypotenuse, and C squared minus A squared equals B squared if we're trying to find the length of a leg. So now what we're going to do is we're going to go ahead and use those in a couple of examples here. So the first one we have a right triangle. A is 6 centimeters, and B is 8 centimeters. And C, the hypotenuse, we're not sure of the length there. So we have to find out how long the hypotenuse is in this first example. Because we're using the hypotenuse, we want to use the form that has a squared plus b squared equals c squared. And then what we can do is we can just plug in what we already know. We know that a is 6, so this is going to be 6 squared. We know that b is 8. It's going to be 8 squared. And we're not sure what c is. That's what we're going to find out. If you're not sure of your perfect squares, you can use a calculator at this point, but 6 squared would be 36, and we're going to add that to 8 squared, which would be 64, and that's still equal to our hypotenuse squared, or c squared. 36 plus 64 comes out to be an even 100, which is still set to c squared. And then the opposite, we have to solve for c. We can't just have c squared. So the opposite of squaring something would be taking the square root, and so we need to do that on both sides, the square root of both sides. So the square root of c squared, we're just going to get c, and the square root of 100 would be 10. So we can come up here, and we found out that our hypotenuse is 10 centimeters. So that would be an example of where you would solve for the hypotenuse if that was the length that was missing. Another example is, what if we had the length of the hypotenuse, but we were missing one of the leg lengths. So in this example, let's say that the hypotenuse is 13 meters, and let's say the shorter leg is A, and that is 5 meters. And in this case, we're going to find out our missing length of B. We're not sure the length of B, and we need to find that out. So we need to use the other version of the Pythagorean theorem, which is c squared minus a squared equals b squared. And this is the point where you could fill in what we already know. We already know c and a, and we're not sure of b. That's why b is on the other side of the equation there. So here we have 13 squared minus 5 squared equals b squared. And that's what we're going to find out, is what the length of b is. So 13 squared, once again, you can use your calculator. These are getting up there a little bit, but 13 squared, 13 times 13 should be 169, minus 5 squared would be 25, and that is going to be equal to b squared. Then if you subtract that out, 169 minus 25 should be 144 equals b squared. And then the opposite of squaring something would be taking the square root. Take the square root of both sides, and we get b equals 12. That is our solution, which means that we can come back up here and see that b is 12. Oh, we changed it to meters, not centimeters. 12 meters. So that would be an example of finding or solving for the length of a leg. The next activity that you're going to have at this station is through Google Classroom. You should have a link to a quick concept check through the formative website. So make sure that you get those 3 questions completed before you rotate to the next station. I'm sure I'll be rotating around, roaming around if you have any questions. But I hope you found this video helpful.